Concepts in review, glaciers and glaciation. 18.1 Glaciers, a part of two basic cycles. Explain the role of glaciers in the hydrologic and rock cycles and describe the different types of glaciers, their characteristics, and their present-day distribution. Key terms: glacier, valley glacier, alpine glacier, ice sheet, sea ice, ice shelves, ice cap, outlet glacier, Piedmont glacier. A glacier is a thick mass of ice originating on land from the compaction and recrystallization of snow and shows evidence of past or present flow. Glaciers are part of both the hydrologic cycle and the rock cycle because they store and release fresh water, and they erode and transport rock material. Valley glaciers flow down mountain valleys, while ice sheets are very large masses of ice, such as those that cover Greenland and Antarctica. During the last glacial maximum, Earth was in an ice age that covered large areas of the land's surface with glacial ice. When valley glaciers leave the confining mountains, they may spread out into broad lobes called Piedmont glaciers. Similarly, ice shelves form when glaciers flow into the ocean and spread out to form a wide layer of floating ice. Ice caps are like smaller ice sheets. Both ice sheets and ice caps may be drained by outlet glaciers. Question: what term is applied to the ice at the North Pole? What term best describes Greenland's ice? Are both considered glaciers? Explain. 18.2 Formation and movement of glacial ice. Describe how glaciers move, the rates at which they move, and the significance of the glacial budget. Key terms: firn, plastic flow, basal slip, zone of fracture, crevasse, zone of accumulation, snow line, equilibrium line, zone of wastage, ablation, calving, iceberg, glacial budget. When snow piles up sufficiently, it recrystallizes to dense granules of firn, which can then pack together even more tightly to make glacial ice. When ice is put under pressure, it will flow very slowly. The uppermost 50 meters, 165 feet, of a glacier doesn't have sufficient pressure to flow, so it breaks open in dangerous cracks called crevasses that occur in the zone of fracture. In addition, most glaciers also move by a sliding process called basal slip. Glaciers move at a slow but measurable rate. Fast glaciers may move 800 meters, 2,600 feet, per year, while slow glaciers may move only 2 meters, 6.5 feet, per year. Some glaciers experience periodic surges of sudden movement. A glacier's rate of flow does not necessarily correlate to the position of its terminus. Instead, if the glacier has a positive budget, in which accumulation exceeds wastage, the terminus will advance. If calving of icebergs, melting, or other forms of ablation exceed the input of new ice, then the glacier's terminus will retreat. Even a retreating glacier is still experiencing downstream flow. Question: this image shows that melting is one way that glacial ice wastes away. What is another way that ice is lost from a glacier? What is the general term for ice loss from a glacier? Robbie Schoen/Photo Researchers, Inc. 18.3 Glacial Erosion. Discuss the processes of glacial erosion. Identify and describe major topographic features created by glacial erosion. Key terms: plucking, abrasion, rock flour, glacial striation, glacial trough, truncated spur, hanging valley, paternoster lake, cirque, tarn, col, arate, horn, rochemoutonnet, fjord. Glaciers are powerful agents of erosion and acquire sediment through plucking from the bedrock beneath the glacier, by abrasion of the bedrock using sediment already in the ice, and when mass wasting processes drop debris on top of the glacier. Grinding of the bedrock produces grooves and scratches called glacial striations. Glacial troughs have a distinctive U-shaped profile, very different from a stream-carved mountain valley, with its typical V-shaped profile. Lining the edge of the valley may be triangle-shaped cliffs called truncated spurs. Higher up, hanging valleys mark the spots where tributary glaciers once flowed into the main glacier. At the head of a valley glacier is an amphitheater-shaped cirque, which may or may not hold a small lake called a tarn. Other glacial lakes in the bottom of the valley resemble beads on a string and are called paternoster lakes. The intersection of two cirques produced by glaciers flowing in opposite directions forms a col. If two glaciers flow parallel to each other, their troughs may intersect in a knife-edge ridge called an arate. A high point that had multiple glaciers flowing away from a point in a radial array may leave behind a pyramidal horn. Protrusions of bedrock may be glacially abrade on their upstream side and plucked on their downstream side. This produces asymmetric knobs of bedrock called rocs moutonnées. In coastal mountain settings, a glacial trough may be eroded below sea level and subsequently flooded by the ocean to become a fjord, a narrow steep-sided inlet. Question: examine the illustration of a mountainous landscape after glaciation. Identify the landforms that resulted from glacial erosion. 18.4 Glacial deposits. Distinguish between the two basic types of glacial drift. List and describe the major depositional features associated with glacial landscapes. Key terms: glacial drift, till, glacial erratic, stratified drift, lateral moraine, medial moraine, end moraine, ground moraine, drumlin, outwash plain, valley train, kettle, ice contact deposit, came terrace, esker. Any sediment of glacial origin is called drift. The two distinct types of glacial drift are till, which is unsorted material deposited directly by the ice, and stratified drift, which is sediment sorted and deposited by meltwater from a glacier. The most widespread features created by glacial deposition are layers or ridges of till, called moraines. Associated with valley glaciers are lateral moraines, formed along the sides of the valley, and medial moraines, formed between two valley glaciers that have merged. End moraines marking the former position of the front of a glacier, and ground moraines, layers of till deposited as the ice front retreats, are common to both valley glaciers and ice sheets. Stratified drift can be deposited immediately adjacent to a glacier or carried some distance away and laid down as outwash. Streams draining an ice sheet produce a broad outwash plain beyond the end moraine. A similar feature hemmed in by the walls of a mountain valley is called a valley train. Blocks of ice buried by the sediment may melt to produce depressions called kettles. Kames are mounds or steep-sided hills of stratified drift that represent the former positions of sediment-filled lakes on top of, or within, the glacier. Kame terraces are narrow masses of stratified drift deposited adjacent to a stagnant glacier. Meltwater streams flowing through tunnels in the ice may leave behind sinuous ridges of stratified drift called eskers. Question: examine the illustration of depositional features formed in the wake of a retreating ice sheet. Name the features and indicate which landforms are composed of till and which are composed of stratified drift. 18.5 Other effects of Ice Age glaciers. Describe and explain several important effects of Ice Age glaciers other than erosional and depositional landforms. Key terms: proglacial lake, pluvial lake. Glaciers are heavy, so heavy that they can cause Earth's crust to flex downward under their tremendous load. After the glaciers melt off, that weight is released, and the crust slowly rebounds vertically upward. Ice sheets are nourished by water that ultimately comes from the ocean, so when ice sheets grow, sea level falls, and when they melt, sea level rises. At the last glacial maximum, global sea level was about 100 meters, 330 feet, lower than it is today. At that time, the coastlines of the modern continents were vastly different. The advance and retreat of ice sheets caused significant changes to the paths that rivers follow. In addition, glaciers deepened and widened stream valleys and lowlands to create features such as the Great Lakes. An ice sheet can act as a dam by trapping meltwater or blocking the flow of rivers to create proglacial lakes. Glacial lakes Agassiz and Missoula both impounded tremendous quantities of water. In Lake Missoula's case, the water drained out in huge torrents when the ice dam periodically broke. Pluvial lakes existed during the height of the Ice Age but occurred far from the actual glaciers, in a climate that was cooler and wetter than today's. Lake Bonneville is a classic example that existed in the area that is now Utah and Nevada. 18.6 The Ice Age. Briefly discuss the development of glacial theory and summarize current ideas on the causes of ice ages. Key terms: Quaternary period, Tillite. The idea of a geologically recent ice age was born in the early 1800s in Switzerland. Louis Agassiz and others established that only the former presence of tremendous quantities of glacial ice could explain the landscape of Europe, and later North America and Siberia. As additional research accumulated, especially data from the study of seafloor sediments, it was revealed that the Quaternary period was marked by numerous advances of glacial ice. While rare, glacial episodes have occurred in Earth history prior to the recent glaciations we call the Ice Age. Lithified till, called tillite, is a major line of evidence for these ancient ice ages. Several reasons explain why glacial ice might accumulate globally, including the position of the continents, which is driven by plate tectonics. The Quaternary period is marked by glacial advances alternating with episodes of glacial retreat. One way to explain these oscillations is through variations in Earth's orbit, which lead to seasonal variations in the distribution of solar radiation. The orbit's shape varies, eccentricity, the tilt of the planet's rotational axis varies, obliquity, and the axis slowly wobbles over time, precession. These three effects, all of which occur on different time scales, collectively account for alternating colder and warmer periods during the Quaternary. Additional factors that may be important for initiating or ending glaciations include rising or falling levels of greenhouse gases, changes in the reflectivity of Earth's surface, and variations in the ocean currents that redistribute heat energy from warmer to colder regions. Question: about 250 million years ago, parts of India, Africa, and Australia were covered by ice sheets, while Greenland, Siberia, and Canada were ice-free. Explain why this occurred.